Hello again and welcome to this series of videos where we're looking at the Gossen Metrawatt Metrahit Ultra. This is model M248B. This is a 310,000 count meter. It's rated for Cat 4 300 volts. And again, this series of videos is just to show my appreciation of hitting 2,000 followers. I think that was a pretty good milestone to reach. So during my initial checkout of the Metrawatt, I had pointed out that it looks like this meter may have a quirk. So I've gone ahead and shorted out each one of these meters with a test lead. Then I've set them all to their highest sensitivity range. So we can see the SEM DT9939 and the Unity UT61E on the right can only resolve down to 10 microvolts. The rest of the meters can all resolve down to 1 microvolt. So this is what I want to show you. If I put my hands nearby the SEM meter, you can see this is very stable. There's no disturbance at all. Looks like there may be some disturbance with the Unity. Looks like our Bryman BM869S is also very stable. This is the TPI 194-2. Again, you can see no effect. And the Unity UT61E, again, no effect. But look what happens with this Gossen. I'm just going to move these meters over a little bit. Get them out of the way and watch what happens. Did you see that? I'm not even touching anything. I'm just bringing my hand close to the meter. Look at that. Seems to be more sensitive down towards the leads, but notice if I'm touching the leads, you see down in here, again, I'm not even touching the meter. So what I'm going to do now is just install this small shorting bar. Look at this. Again, I'm not touching that bar at all. I'm just putting my hand, touching the case. That's like 500 microvolts right there. You can see the Bryman. Look at this. I'm touching the leads. I'm touching all around it. See? There's basically no effect. Here's with the TPI. I'm touching the meter. You know. You can see again, there is no effect. The UT181A. Let's try high resolution, and then let's see if we can do a min-max off of that. Oops. I don't know if you can see that with the camera, but just get the glare off of it. See that we've captured 1.623 millivolts. Yeah, so I'm not sure what's going on. You can see I just kind of slide my hand along the side. I'm not even really causing any sort of vibration. Look at that. 4 millivolts. Let's just try it with a metallic screwdriver here. See, I don't think it's vibration. Look at this. Yeah, it almost looks more like it's coupling into my hand. Well, that's very bizarre. I've never seen a meter that would do this before. I would think that this would be a problem. I noticed this when I was trying to make measurements with the meter on the test box, that it just seemed like it was very unstable. It was just difficult to get some of these very precision numbers up on the screen. And it seemed like I would move and things would just go flying. So it makes sense. There's definitely something in the design of that. You set 320 millivolts or 320 microvolts just from me waving my hand around here. I mean, I'm probably an inch away from it. Bizarre. Maybe somebody from Germany could tell me what's going on with this thing. What we'll do is just switch the meter over to AC mode. And we'll manual range up. You can see it has no effect in the AC mode. Let's try AC plus DC. Oh. Look at this. So this is in resistance mode. Look at right here. See how it's shifting up? Again, I'm not touching the meter. You can see the gap. I'll take my hand away. Yeah. So we're in a small RF chamber right now. You can see I have the Gossen with me. So one of the things I'm concerned about is that I'm acting as an antenna and then somehow capacitively coupling into the meter. So I thought what I'd do is try this without having any kind of an RF source. So let's just see. Oh yeah. See this? It still behaves the same way. You can see I'm not touching the meter. Let me just try touching the ground of the chamber here. You can see that's not having any effect as well. It's just a chip tube. Let's just try it with that. Well, you can see, look at the effect on that. Again, you can see I'm not even touching the meter. Again, I'm going to touch the chamber. It's very bizarre. I've never seen a meter do anything like this. Huh. Well, it's not RF. You can see I just have a banana to BNC adapter. Then I also have a inline 50 ohm terminator and a section of coax. So what I'm going to do is plug this in so the ground side is to the common. And now I'm just going to wave this coax by the side of the meter. Wow. So even though the outside braid of this is tied to the common of the meter, you can see it's just having a very huge effect. It's just a different IC tube, and you can see the effect. What I have here is a piece of mu metal. I'm just going to lay that alongside here. You can see I'm actually touching the metal right now, and there's no effect. You can see setting that mu metal next to it makes a huge difference. So I basically have the meter now laying across our little plane. You can see it still affects it. Alright, so there's one other thing I'd like to try. If I just lay this piece of foil up against the side of the meter this way, and now let's try it. Well, that cut it down. Let's try it with our hand. So one of the big problems with this is, of course, if I go to zero out this little bit of offset, I bring my hand up here to push the button on the meter, you can see it just goes all over the place. I'm not even really pushing on the button yet. I'm just there holding my finger up near the button. I'm not even touching it. Watch. See this? So just bringing my finger in close proximity to the button causes that kind of an error. I don't know how they could sell a meter like this. To me, this is pretty much worthless. So now the question is this common to all these meters, or is this meter actually got a problem? You know, I have not taken this meter apart at all, other than to look inside the fuse compartment and install the batteries. But anyway, so this is the way the meter was actually shipped from the factory. You can see the meter has a current build date. It was just calibrated a couple months ago. It's time for the sealed cookie can. I've got way too much ambient noise around here to be able to look at this. So I've just got a small BNC connector soldered into the side of this. So currently I have the radio turned off, and I'm just going to go ahead and start closing the can. I'll just seal that right off. Let's give you an idea of the baseline. So now what we'll do is turn the meter on. You can see our dominant peak is at 1.2 gigahertz. Again, our upper frequency right now is 2.4 gig. Let's just go ahead and increase that. So we're now sweeping up to 6 gig. It looks like all the emissions are right in this area here. As well. DC, DC, and DC. Okay. sounds like a dead animal when you turn it off. Okay. So watch this. See that?
Yeah.
I've seen it get as high as like 500 millivolts or 5 millivolts, right? And the problem is you'll come in here to clear this thing out, to zero it, and as soon as you reach your hand up here, a lot of times
you're already throwing it out of whack, and pull away, it's still not zero.
right, yeah. So it's like, well, you know, and it doesn't seem to have anything to do with the radio being on and off. Oh, Mr. Fuzzy. Maybe it is static. Dang. There's 10. 12. Here, we'll do a panorama. No audio track here. Oh, you're fine. Get a sideways shot of the antenna. During the RF testing, we were sweeping between 80 megahertz and 3 gigahertz at 10 volts per meter. We ran both the horizontal and the vertical. The meter appears to be most susceptible when it's getting hit off the right-hand side. And that's basically the same thing that I've seen with my bench testing. It looks like there's two problems with the meter. One is it looks like it's sensitive to static fields. So in the last test you saw I had a piece of foam block. And basically what I ended up doing is rubbing that across my hair and then holding alongside the meter, and you saw I had deflections up in about 20 millivolts with that. The meter emits a signal of about 1.2 gigahertz. So I think what could be happening is that RF could be deflecting off of my hand and coupling back into circuitry on the meter. So I believe that this is actually a design problem with the meter. My guess is that it's something in the layout. So here you can see on May 10th I wrote services at GossenMetrawatt.com, and this is what I wrote. I recently procured a Metrahit Ultra and I suspect it may be defective. The meter is brand new and has never been apart beyond installing the batteries. It has not been exposed to any voltages beyond 10 volts or so. It has not been dropped. In the high resolution DC volt mode with the inputs of the meter shorted with a short jumper, if I move my hand near the meter, it will show signals into the millivolts. The problem is not vibration, as I don't have to touch the meter. If I use a longer jumper, I can touch the jumper and see very little effect. Inside an RF chamber, I see the same effect. It seems to affect the resistance mode as well. Capacitance, AC-DC microamps, AC volts are all not affected. If I place one hand on the chamber's wall and sweep along the meter with the other, I still see the effect. Again, I don't have to touch the meter. I have my hand about an inch away to see this effect. I tried using a plastic IC shipping tube, holding it on one end and using the other end to sweep next to the meter. I again see the same effect with or without me touching the other hand to the chamber wall. These shipping tubes are somewhat conductive. This meter has a Bluetooth radio built in. Turning it on or off seems to have no effect. I took a banana to BNC adapter and connected that to the meter's input, then inserted an inline 50 ohm terminator. Connected to that was about a 3-foot piece of RG58U coax. The braid was connected to the common of the meter. Sweeping the coax by the meter causes the same effect. I then laid the meter on some foil, wrapped the foil around the coax and the terminator, and again sweeping the coax near the meter causes the effect. I then took the foil, wrapped it around the outside of the meter, just floating in free space. Sweeping the coax on my hand had little effect. However, bringing my finger near the null button caused the meter to again wander several hundred microvolts. The problem with this design is, say you want to measure some 100 nanovolt signal. You short your leads, go go to 0 out the offset of the meter, and the meter wanders. So now your 0 is 200 nanovolts sort of thing. It's the same for the resistance, which is where I first noticed the problem. I have a few Korean and Chinese meters that can resolve down to the microvolts as well. These are all very stable. The paperwork shows the Ultra had passed all of its functional tests, but I assume these are all automated, and I doubt the operator would be moving near the meter during the tests. I suspect you have an RF source that's capacitively coupled to my hand and then causing some sort of a loading problem. Looking at the emissions, it seems that with the Bluetooth turned off, the meter generates a fair amount of RF in the 1.2 gigahertz range. This seems to be the dominant area of emissions. Perhaps the 1.2 is multiplied up to get the 2.4 gigahertz for the Bluetooth, and that oscillator is always active. Can you confirm if this is normal for the Ultra, or if there's some other test I could perform to tell you if the meter is defective? So again, I sent that email on May 10th, and unfortunately I have yet to hear from them. So I think what I'd like to show you next is how the Bluetooth interface works with this meter. I'm going to go ahead and write some LabVIEW software for it, and then maybe we'll do a drift study. Basically what I'd like to do is give Gossen an opportunity to respond to this video. So I'm hoping that they're going to step up and tell me that either this meter does have a design problem, in which case I'll just go ahead and tear it apart and we'll continue on with this little assessment of it. The other option is they're going to tell me that the meter is defective. In that case, I can just go ahead and return it. We can get a brand new meter that hopefully solves the problem, and then we can start the review over again. And of course there's the third option, and that's that they don't contact me. And if that's the case, well, the meter is going to come apart and we're going to try to figure out what's exactly wrong with their design, and we'll critique it. So I think that's going to be it for this video. Hope you enjoyed it. Hope you didn't find the RF testing too boring. I know those tests are kind of long and dull to watch, but I'm sure there's a few of you who have not seen an RF chamber, so I thought I'd give you a little view of what's inside of one. I think that's going to be it. Till the next video. Later.